and salam sejahtera. In this video, I will record about chapter 4. So I'm gonna start it all over again in case you guys miss anything lah. I don't think I'm gonna upload the mid recording, but instead I'm gonna focus on this one. So chapter 4 actually have about 7 subtopic. So in this video, I've covered a few subtopic. So magnetic field, as you guys know, you have two types of magnet. One is permanent magnet, another one is non-permanent magnet. So for permanent magnet, you can categorize, example for permanent magnet is like bar shape magnet, U shape, and then earth magnetic field. Okay, all these three, make sure you know how to draw. You can always refer to your lecture notes, or you can refer to the internet. For non-permanent conductor carrying current, you have three types: long straight wire, circular loop, and solenoid. Okay, each one of these you have a specific formula, and for solenoid you actually have two formula. So for calculation, most of the time they will ask you to calculate about conductor carrying current here. Even if they ask you to calculate magnetic field over here, maybe it doesn't have any specific formula. So maybe they give you a few criteria and then you can calculate the B instead. But for formula, you'll be using for this part. Okay, for long straight wire, make sure you know how to determine the direction of magnetic field due to current direction. So like I told you previously, your thumb will be your current, your fingers will be your magnetic field. So you can try this one again. Put your thumb over here, so this is basically your thumb, and all your fingers will be something like this, right? So okay, ada 3 je finger dia. It's okay. So this finger actually pointing out from the surface, okay, and this one is actually pointing into the surface. So that's about that. So the magnetic field is actually something like a circular motion like that, okay. Tapi kalau kita potong, dia hanya nampak in or out of the page. You have one formula which is B equals to mu naught I over 2 pi L. And then for circular coil, you can use the same method. Okay, you can put your thumb, but in this case, I use my finger as my current direction. So I do my finger here, and then you can see that my thumb is actually pointing into the page like this. Okay. Again, I will show you in class. I don't think this one should be a problem. So you have two formula. This formula only represent at the center lah. These two formula actually pretty much the same formula, except the difference is you have n. N is means numbers of turn. And then you have solenoid. So you have to be careful with solenoid and numbers circular loop, because solenoid have multiple loop, and sometimes circular coil has multiple loop as well. Okay, the difference is solenoid have length over here, so that's the difference lah. So for the formula, you have two formula. One if you want to calculate at the center here, another one is if you want to calculate at the end point. Okay, it depends on the question, and most of the time they will give you values of n and value of L. Sometimes they give you n over L. N over L is actually numbers of turn per unit length. Okay. Okay, now moving on to the force on moving charge particle. So if you have a charge that is moving across a uniform magnetic field, you will expect that a force will be applied onto the charge. Okay, the formula would be F equals to BQV sin theta. I don't think there will be any problem to use this formula. The problem might comes from the direction. Okay, so I'm gonna stick with one method, which is what I call right hand palm rule. So we only use right hand, tak ada kiri, tak ada apa, just kanan je. And then the thing is, when you use this hand, your fingers yang banyak ni represent the magnetic field. Okay, your thumb, sebab gambar ni tak ada gambar macam ni, so your thumb is actually like this, represent your velocity direction. Okay, if the charge is positive, then you can slap forward. If the charge is negative, means you can backhand it, slap backward. So you don't have to use two hand, but you can slap it forward ataupun slap backward. Tapi kamu jangan lambai-lambai. Kalau lambai-lambai dia memang tak ditentukan. So move it once. Kalau ke depan positif, negatif ke belakang. Okay. And then remember that the angle here is actually angle between V and B. Okay. And then you have one key thing. If you have a charge moving on into uniform magnetic field, the motion could be circular motion. Dia boleh jadi circular motion. So if it becomes circular motion like this, so in the question normally they will state specifically lah that the direction of the charge now move in circular motion. So when it move in circular motion, this one is valid straight away, where FB is equals to BQV sin theta. And if you guys still remember from last semester, it's actually equals to mv squared over r. So cancel out. Okay, sin theta will always be 1 in this case because your v is always in one axis, one plane, and then your b is in this case always pointing upwards, out of the page, sorry. So in that case it will always be 90 degrees. That's why it's become 1. So rearrange, you get this one. Now you also have formula of period and frequency here. Okay, jarang pakai, most of the time you pakai this one. Okay, this is an example question for circular motion. I think for the past few years dia hanya tanya sekali je. You can try to look at past years and kamu jumpa satu soalan je, I think, kalau saya tak salah lah. So in this case it shows a proton with a speed of, so it has a speed entering a region of uniform magnetic field between two parallel plates are separated by distance 0.18. So the distance here is 0.18. So I'm going to write that down. Okay, and determine the direction of magnetic force on the proton and sketch its trajectory when it's entered the region between the plates. So you can try to decide here. So let's say if the proton is now over here, so positively charged particle, you can try to use your right hand palm rule where your fingers is pointing into the page, magnetic field is into the page. The direction of V is to the right in this case. So you will see that the force is actually going outwards. And because this one is positive, and so you slap it forward. And then because of this, the particle will actually bend a little bit, and eventually they can reach this point. Okay, at this point, your velocity now is in this direction, tangential to the direction, and then your force is actually now pointing to the left. You can try it and you can double check it. Okay, so as a result you will have a trajectory something like this. Okay, a circular motion. Okay, only half of it like this. Okay, question number 2. What is the maximum magnitude of the magnetic field so that the proton does not hit the opposite plate? So actually you want to have the maximum curve over here. So when you want to have the maximum curve, I think question maybe terbalik kot. They actually want to find the minimum. Okay, bukan maximum. So the radius here will represent the radius of the circle. Okay, so you want to use this one as your radius, 0.18, and you can substitute mass of proton. This one you can get from the front book, tutorial book. Velocity is given, straight away masuk. Q is the charge, proton dengan electron the same charge. Now you can calculate magnetic field straight away, which is 0.128. Okay, so I think I'm going to stop it now.